Ready-made mathematics YouTube training videos. Teacher and teaching assistant training. This week is a continuation of the mental multiplication strategies. We're now up to day 6. What we're looking at today are doubling strategies. We'll first of all have a brief look at how important doubling really is and how knowing our doubles is so useful in basically lots and lots of different elements of mathematics. That'll be a continuation from what we looked at with the addition of double strategies a few weeks ago. What we're then going to look at are 2 specific strategies that really help us. If we know our doubles, then we can use doubling strategies to support our understanding and ability to get the answer to mental multiplication questions. So I hope you enjoyed the session and that you'll find quite a lot of different ways of using and applying your knowledge of doubles. So let's start off with knowing and learning our doubles. We're not going to talk about this much because actually in the first couple of weeks we did a whole session on double and adjust and did a lot of discussion on knowing and learning doubles. If you do look back at those videos, you will find a lot of ideas and activities. But these slides that you can see now are from the sense of number visual calculation policy. What we can see first of all is 2 ways to double 17. We can do the standard double 10 and double 7 if we know those doubles and then add them together. 20 and 14 is 34. Or alternatively, think of 17 as 15 and 2. That's even easier. Double 15 is 30 and double 2 is 4. In a similar way, we can use double 37 as double 30 and double 7, which gives you 60 add 14, or just double 35 and double 2, which then gives you 70 add 4. There's a similar version there for years 4 and 5 for double 480. And then just one way of doing a quick decimal double, which is double 3 and double 0.7, which would give us 7.4. Again, we could actually do double 3.5 and double 0.2, and that would, in a similar way to 37, and that would also give us 7.4 as well. So we're not going to really cover that in the classroom today, but it's worth making sure that the children are really secure at knowing and understanding their actual doubles.
Hello and welcome to day 6 of the multiplication strategy videos. I hope you've enjoyed the first 5 days where we've taken you through a range of different strategies for children, mainly in upper key stage 2, to develop a real repertoire of strategies for mental multiplication. We started off looking at the whole lot, and then over the next 4 days we've looked at reordering, we've looked at partitioning, we've looked at round and adjust, and yesterday we looked at factorising. As you can see from the board, what we're going to be looking at today are doubling strategies. These are relatively straightforward. There won't be quite as much visual apparatus for today. There'll be a couple of little examples that I want to take you through. But really today is just about using and knowing your doubles. Now in the actual visual calculation policy that you'll see shortly on the PowerPoint presentation, you'll notice that there are 3 different parts to doubling. There's doubling up, there's doubling facts, and there's also learning doubles. If you think back, or if you look back to the first set of 10 videos that we did, there is a whole session on learning and using doubles. So if you want some ideas and activities for actually learning doubles, go back to the first set of videos and you'll find a whole range of those as part of the mental addition strategies. So I'm not going to particularly cover learning doubles. I'm going to assume that children, as part of this activity, have already got a really good bank of doubles in their head that they've built up from year 1 to year 4. We've now got that bank of doubles in our head. Can we use them to really help us with our multiplication? And I hope what you'll find today is actually, when you know your doubles, there's so many simple ways to turn complex calculations into ones that are much more straightforward. And that's what we're going to be doing over the course of this session. Let's just start off by taking a really easy times table and looking at the double up strategy. The double up strategy is one that a lot of schools do teach quite regularly, especially when we're coming to developing our times tables facts and learning future facts. If we started off with the 3 times table, we know that 3 multiplied by 1 is 3. We know that 3 multiplied by 2 is 6. But rather than count 3, 6, 9, 12, 15, I just want to look at certain facts, the doubling up facts. 3 times 1, 3 times 2, 3 times 4, which is 12, and 3 times 8, which is 24. Now, those particular facts are already just known facts in the 3 times table. But as you notice, what I've done is I've left the ones that double up. Times 1, times 2, times 4, and times 8. And hopefully what you'll see from the products is you'll see that actually the products double in exactly the same way. If we've got 3 times 1, we double it, we get 3 times 2, therefore the product doubles. We then go to 3 times 4, and therefore the product doubles. If, for example, I just took an abacus and just made it really quickly, there's 3 multiplied by 1, and then when I do 3 multiplied by 2, you can see straight away we've got double the amount. If I now go to 3 multiplied by 4, you can see I've doubled the amount again, which now gives us 12. And if I then go to 3 multiplied by 8, I've got to double this, and what you end up with, 3 multiplied by 8, 3, 6, 9, 12, 15, 18, 21, 24. So we've doubled the amount each time, and the product doubles as well. That means that even if we don't know 3 multiplied by 16, if someone was to say, Anthony, what's 3 multiplied by 16? And I wasn't sure of the answer, well, what I do know is 3 times 8 is 24. Therefore, if I double it, 3 times 16 is 48. What's 3 times 32? Well, actually, that one is a very easy one as a partition. 3 times 30 and 3 times 2. But just to double check, 3 30s are 90 and 3 2s are 6. But we can also use the doubling strategy. I know 3 times 16, and if I double it again, I'll get 3 times 32. So if you do see any of these numbers, 4, 8, 16, 32, 64, using the doubling strategy, we can even do 3 times 64. And if we double that, we'll get 192. Now you probably wouldn't use it for those ones, but it's certainly very useful for 3 times 16. What we're going to do now is take a 2-digit number and apply the same strategy. And let's see how it can help us with slightly bigger numbers. So what I've done here is I've just put a range of different numbers that we could use the doubling up strategy to help us with. Let's imagine you were faced with the calculation 17 multiplied by 4. We've already learnt we could use the partitioning strategy. 10 times 4 is 40, 7 times 4 is 28, and add them together. But now we've got an alternative. It's a multiply by 4, therefore we can just double and double. So 17 times 1 equals 17, double that, and that should be a known double by the end of year 3. 17 times 2 is 34, and definitely we can double that very easily and get us to 68. So that just gives us an alternative way of getting to 17 multiplied by 4. The next one, as the numbers get quite a little bit more complex, we'll rub the 17 out now, we've now got 36 multiplied by 8. Again, it's always worth checking with the partition. 8 times 30 is 240, 8 times 6 is 48, add them together, we know the answer will be 288. But now there's another alternative way to get there. All we need to do is use our doubles. 36 multiplied by 1. Well, that's easy. That's 36. Double again, and again this should be a known fact by the end of year 4. Double 36 is 72. That's a much easier one to double now. Double 72 is 144. And again, a very easy one to double. Double 144 is 288. It's actually a really good strategy whenever you spot that number. Multiply by 8, we've got a few alternatives now. We can just double up to 1, to 2, to 4, and to 8. Now the other two, I'm probably getting a bit silly, but just to look at the examples. But imagine a calculation. It does look quite complicated. 125 multiplied by 16. How are we going to use the strategy for that one? Again, very, very straightforward. 125 just jumps out as a number that's going to be an easy double. 125 multiplied by 1, we double up to 250, we double up again to 500, we double up again to 1,000, and we double up again to 2,000. Imagine giving that to children in year 5 or 6 and just showing them that strategy. It's kind of mind-blowing how quick and how easy that strategy is to be able to do a calculation as seemingly difficult as 125 multiplied by 16. So again, if you want to prove it, you can do 16 times 100, 1,600, and 16 times 25, which is 400, but that way is a really, really good way to do it. The one I've left towards the end, I've left 27 multiplied by 32. Now again, you would probably do a long multiplication strategy, but imagine, again, for greater depth in year 5, 6, just try the doubling strategy. Let's just see how easy it is. Let's start us off, 27 multiplied by 1. Well, that's easy. 27. I think the hardest bit is then this next bit, double 27. Again, by the end of year 4, that should hopefully be quite quickly. Double 27 is 54. Now it gets quite easy. Double 54, double 50 and double 4, double 108, 216. Again, a relatively easy double. Double 216, again very quick, 432. Double 432, 864. Again, look how quickly we've done that. I think that was quicker than doing a log multiplication calculation. If you want to be silly, you can go a little bit further. 27 multiplied by 64, 1,600, 120, so 1,728. Again, that's a higher level one. Have a little play. It's a great one to teach children and just let them practice so they start to recognise multiplying by 8, 16, 32, 64 could be done, as long, obviously, as the doubles are relatively easy. If we end up with complicated doubles, then obviously go back to a different strategy. But I hope you found that one a useful one to do.
So, as we've just seen, this is the doubling up strategy. We've looked at these examples in the classroom, so I won't go through them again. I just thought it was worth showing you the examples from the visual calculation policy. Again, if you're looking at this and you think it's something you'd be interested in for your school, have a look at senseofnumber.co.uk, where you'll find that hundreds and hundreds and hundreds of slides that cover concrete pictorial, mental and written methods. You can see here examples for multiplying by 4, multiplying by 8 and multiplying by 16.
What we're going to do now is move on to the idea of doubling facts. This is again a fairly straightforward strategy, and it's one that is part of just learning about normal multiplication, and it links to the tables really effectively. What we're looking at now is the calculation 7 multiplied by 3. As we can see, there are 7 whites, 7 reds and 7 yellows, all set out egg box style or 10 frame style as 5 and a bit. What happens overall if we double the amount of egg boxes and obviously keep the same amount in each egg box? Let's have a look in a second. Let's first of all see how many we've got. Well, we've got 7 multiplied by 3, and we can see the answer. We either know 7 3s are 21, or we can see 5, 10, 15, and then another 6, and 15 and 6 gives us a total of 21. Let's pause the video now while I introduce double the amount. And what we can now see is 7 multiplied by 3 again. So we've actually got now 7 multiplied by 6. So we started off with 3 7s, and now we've got 6 7s. So as you can see, we've doubled the tables fact. We've got 7 times 3 and introduced a further 7 times 3. That obviously gives us now 7 multiplied by 6. What's the answer? Well, let's have a look. If we read across the top, 5, 10, then go to the next box, 15, 20, then go to the yellows, 25, 30. So we can see there are 6 5s, and we can also see 6 2s. 30 and 12. That gives us a product of 42. So over here, 7 times 3 is 21. And obviously again, here's another 7 times 3 is 21, which means altogether 7 multiplied by 6 gives us a product of 42. So it is quite clear to children as well, if you double the amount in the tables fact, the product is bound to double. What we're now looking at, well, I'll let you have a look. What calculation do you think this represents? Hopefully, what we can see is 15, a 10 and a 5, or 1 10 and 5 1s, repeated 6 times. So we take 15 and we multiply it by 6. Again, let's have a quick look at what the answer is. Well, looking at the 10s, we can see 10, 20, 30, 40, 50, 60. And looking at the 1s, we can see 5, 10, 15, 20, 25, 30. So altogether, 15 multiplied by 6 gives us a product of 90. Let's now make it 15 multiplied by 12. Let's have a look. So at the top, we can see 15 multiplied by 6 equals 90. What we've now introduced is a further 15 multiplied by 6, which obviously will give us another 90. But what have we got all together? We've actually got 15 multiplied by 12. And as we can see, 15 multiplied by 12 gives us a product of 180. It has to do because we've got a 90. And a 90, double 90 is 180. We can check overall. Let's have a look at the number of 10s. Well, there's 6 10s at the top and 6 10s at the bottom. That gives us 12 10s, or 120. We must also have 12 5s, which is 60, 120, and 60 is 180. So hopefully what we're seeing now is that very, very simple strategy. If we double one of the numbers in the tables fact, then obviously the overall product doubles. So 15 times 6 and 15 times 6 will give us 15 times 12. Let's have a quick look as well at doubling up both facts this time. So I'm going to create a calculation. I'm going to create 3 multiplied by 4. So 3 times 1, 3 times 2, 3 times 3, 3 times 4. So I've got 3 multiplied by 4, 3, 6, 9, 12. What I'm going to do is I'm now going to double one side of that. So I'm going to go from 3 times 4 to 3 times 8. 5, 6, 7, 8. I've now got 3 multiplied by 8, which is 24. So 3 times 8 is 24. What I'm now going to do is double the other side. So I'm going to put 3, 2, 3, 4, 5, 6, 7, 8. And what we've now ended up with is 6 multiplied by 8, which gives us a product of 48. So I'm going to just get a whiteboard out and just show you what we've just done with that particular calculation. Okay, so what we just saw was we started off with the fact 3 multiplied by 4. What we then did was we doubled the 3 times 4 to make 6 times 4. So 3 times 4, which was 12, became 6 times 4, which was 24. So I'll just write those numbers underneath. So 3 times 4, which we know is 12, and 6 times 4, which we know is 24. So what we actually did was we doubled the 3 to give us a 6, and the product doubled. What we then did was we doubled the 6 times 4 to become 6 times 8. That gave us the product of 48. So what we've actually done overall is we started with one fact, 3 times 4 is 12. We then doubled one side to give us 6 times 4. We doubled the other side to give us 6 times 8. And what happened was the product doubled twice. So it's the same idea. If you double one number, the product doubles. If you double the other number, the product doubles again. Overall, you've actually made it 4 times bigger. I've actually drew another little line in there. 3 times 4 is 12, therefore 6 times 8 is 48. It would have worked the other way as well. We could have started with 3 times 4 and doubled this one first. That will give us 3 times 8. 3 times 4 is 24. So 3 times 4 is 12. 3 times 8 is also 24. So whichever way we do it, as long as eventually we double both numbers, you're going to end up doubling the product twice. So it's a really nice one to remember. We're just going to try that once more with one more number, and then we're going to go to the mathematics board. So what I'd like you to do is to look at 4 times 2, a really easy one, and one that's a little bit harder, 6 times 4. All I'd like you to do is double one of the numbers, double the 4, and write the product, the new calculation and product there. Go that way if you want to, double the 2, and write the new calculation and product there. And then let's have a see what happens when you've doubled both of the numbers. So can you fill in all 3 parts of that little diagram? Again, do exactly the same with the other diagram. Hopefully, what you've been able to see, you should know all these answers anyway, because these are all known facts, but this just proves how the strategy works. 4 times 2 is 8, so if we double the first number, we end up with doubling the product. 4 times 2 is 8, 8 times 2 is 16. If we double the multiplier, 4 times 2 becomes 4 times 4. You'll notice those two products are always the same. So whichever of the numbers I double, whether it's the multiplicand or the multiplier, I still end up with a product of 16. I can then double the other number, and again, whichever way I do it, I go from 4 times 4 to 8 times 4, or from 8 times 2 to 8 times 4, and again, the product doubles. So we go from 8 to 16 to 32, from 8 to 16 to 32. Or we just multiply, we double both numbers and multiply the product by 4, and we get the same thing. Again, looking at this one, we'll go through this one much quicker. We know 6 times 4 is 24, therefore either 12 times 4 or 6 times 8 must be 48. They must be double the 24. We've doubled this table's fact to get this one, or we've doubled this table's fact to get this one. Then from 12 times 4, we can double to get 12 times 8. Or from 6 times 8, we can double to get 12 times 8. You'll still get the product of 96, whichever way you go. It's just really worth knowing, because if you ever start off with a calculation that you don't know, let's say you don't know 12 times 8, you can work backwards. We can start with one of those facts and double it up twice. So we're now going to go to the whiteboard, and we're going to try a few of those slightly more complicated ones so that you get the chance to have a go yourself.
Just before we move to the whiteboard, can I just make a quick apology that the next around about 5 minutes or so of video material isn't quite of the right quality. We had a problem with the stand that was holding the camera, and so the angle that at which the next 5 minutes of video is taken is a little bit different from all of the others. But if you just bear with me just for that 5 minutes, then it does go back to normal towards the end of the video. I hope you still find the activities useful.
So now we've seen how the doubling facts strategy actually looks visually. How does that help us when we're given calculations? Now, some of these we may already know, but let's just see how we can make them really, really easy by using a fact that we already know. So let's assume that, let's say we're in year 4, and we don't yet know that 12 times 7 is 84. We've not learnt that as a tables fact. What do we know? Well, what we definitely know is 6 multiplied by 7 equals 42. If we know that 6 times 7 is 42, as we've just proved, we can double that 6. That's going to give us 12 times 7. So if 6 times 7 is 42, 42 basically multiplied by 2 gives us a product of 84. So 12 times 7 must be 84. I want you now, we're going to pause the video, I'd like you to look at all these other calculations. I'd like you to look at 18 multiplied by 9, 16 multiplied by 9, 24 multiplied by 6, and 22 multiplied by 12. Have a look at those calculations and try to work them out. What fact can you use in order to help you work out the product? Well, let's take a quick look. I've just rewritten the calculations in a slightly different place on the board just to make it easier to follow them through. We started with the one that we've already done, which is 12 times 7. This is one of my favourites, 18 times 9. There's many other ways to do it. We can do 18 times 10 and adjust. We can do 9 times 10 and 9 times 8. They'll all work. But what's going to be much easier is to start with 9 times 9. 9 times 9 equals 81. Therefore, 18 multiplied by 9 must be 162. Much quicker than any of the other strategies. Similarly, same idea. If 16 times 9, well, we don't know that. What we do know is, obviously, 8 is half of 16. So 8 times 9 is 72. Therefore, 16 multiplied by 9 must be 144. Again, that's quicker than rounding and adjusting, and it's also quicker than partitioning. Just use the fact we know and double it. This one actually will give us the same answer as the previous one. Rather than doing the 8 times 9 is 72, we're now halving the 24. We know that 12 times 6 equals 72, and therefore 24 times 6 must be 144. The final example, 22 multiplied by 12. Again, I could have either of these. I could make it 22 multiplied by 6, but again, that's not a fact that's particularly well known. Whereas if I have the 22, we get 11 times 12. 11 times 12, 132, which is a known fact. Therefore, 22 times 12 must be 264. This is definitely one of my favourite mental arithmetic strategies for multiplication because I think it really allows you to play with numbers and to make things easy. Let's not start with something complicated. Let's start with a fact I know and double it. We don't really need round and adjust. Let's start with a fact we know and double it. So now I'm going to put a new set of calculations up and let's see how we can extend this strategy even further. Again, linking back to what we looked at with the abacus earlier on.
Again, as before, we've just looked at all these examples in the classroom, but I did think it was worth showing you that these are all available as posters that can be printed out on A4 or A3 and put up onto your working walls in class so the children have got a display and an arrangement of all the different strategies that they need. You can see here the year 3, we work out 8 times 6 by beginning with 4 times 6. Year 5, we work out 16 times 7 by beginning with 8 times 7. And in year 6, we work out 22 multiplied by 12, starting with 11 multiplied by 12. So again, if you are interested, senseofnumber.co.uk.
Now, these examples are the sorts of calculations that I show children a lot when I'm in the classroom. We'll look at something like 16 multiplied by 16, 12 multiplied by 14, or 18 multiplied by 12, and just think to ourselves, what facts do we know that are going to enable us to solve these ones much quicker? Well, if I start with 16 times 16, I hope that one kind of jumps out. We can have the 16, and we can have the 16. We end up with 8 times 8. Well, 8 times 8, straightforward fact, 64. Therefore, 16 times 8 must be 128. Now we double the other side, therefore 16 multiplied by 16 must be 256. So in effect, we've worked out 16 squared really quickly just by starting with 8 squared that we already know and doubling it twice. That will work with any of them. We could work out, 18 squared by starting with 9 squared. So 81, 162, 324. So again, really easy to work out lots of, quite complex calculations. Let's look at 12 times 14. If we have the 12, we get 6. If we have the 14, we get 7. I know that 6 times 7 is 42. It doesn't matter which way around I do this. I'll go the other way. 6 multiplied by 14 or 12 multiplied by 7 will give me 84. And then we go to 12 multiplied by 14. Therefore, must be 168. Again, we've turned that one into a very easy calculation just by doubling twice. The final one, 18 multiplied by 12. Well, we start with a 9 and a 6. Half of 18 is 9, half of 12 is 6. We know that's 54. Therefore, either way around, 18 times 6 or 9 times 12 will be 108. And therefore, 18 times 12 must be 216. The key to this strategy is actually remembering when we see a calculation, I could use the doubling strategy. Let's just strip it back. Let's half it, let's start there, and then let's go forward by doubling it. So hopefully you found that a really useful strategy. What I'm now going to do is just going to finish with maybe 3 slightly more complicated ones, which I'd like you to have a go at in your own time, and then we'll look at the solutions. So for the final 3 calculations, what I'd like you to do is take a look at those 3, decide what calculations we're going to start with. These ones are slightly more complicated, and you might need to go back a little bit further. This is greater depth, just to see if you can manage to start with a simple calculation and use that idea of doubling up the strategy until eventually you get the product. So have a look at 14 times 32, 28 multiplied by 12, 36 multiplied by 14, and let's just see if you can double up and get a product. Let's start off then with 14 multiplied by 32. What we'd originally think, looking at what we did previously, was we'd have those numbers and we'd end up with 7 multiplied by 16. That's still a little bit too complicated, so let's go back a little bit further to 7 multiplied by 8. So 7 multiplied by 8 equals 56. Then we can double up to give us 7 multiplied by 16. We just double the answer, and that gives us the new product of 112. We'll double up again. 14 multiplied by 16 equals 224. And amazingly, 14 multiplied by 32 equals 448. There's no way we'd have been able to do that one that quick using a different strategy. We just doubled up 3 times and got to the answer. Similarly, with 28 times 12, we could start off with 14 times 6. We just need to go back one stage further to 7 times 6. So 7 times 6 equals 42. This time I'm going to just keep doubling the 7 to begin with. So if 7 times 6 is 42, we know that 14 multiplied by 6 must be 84, because that's our simple double. Therefore 28 multiplied by 6 must be 168. We've got a slightly harder double now, just to finish off with. We now work out that 28 times 12, just by doubling this one, well, 160 doubled is 320, because double 16 is 32. So 320 add double 8, so 320 add 16 is 336. Again, if you want to challenge the children to partition it and check, they can certainly do that as well. The final one, 36 multiplied by 14, so we're going to halve it. 18 multiplied by 7, and then we'll halve the first bit again, and we end up with 9 multiplied by 7. This is quite a nice one. We just start off with 9 times 7 equals 63. By doubling up, we can get 18 times 7, which gives us double 63, or 126. We double up again to get 36 times 7, which will give us 126 doubled is 252. And last but not least, we now double the 7. 36 multiplied by 14 will give us 504. So what we've done really is we've turned 3 difficult, complicated calculations, relatively hard ones with long multiplication, just by doubling. We've been able to get the answers really quickly. Very much again for joining me for today's video on doubling strategies. I hope what you've seen today from that video is how useful knowing your doubles are. Obviously, if you don't know your doubles, that whole video will be of no use whatsoever. It takes me right back to what I said when we did the first week of training. We did double and adjust, I think on day 2 or day 3, and we talked about the importance of knowing your doubles. They're not really mentioned in the curriculum very much. There's no specific learning facts for doubles, so it's up to schools to take control of that and say, look, doubles are really, really important. The more doubles I've got in my head, the easier it's going to be for me to obviously develop double and adjust for addition, but also all these fantastic multiplication strategies that that are heavily involved in using doubles. So I hope you found today's video useful. Tomorrow we're going to continue with a kind of doubling strategy. We're going to be looking at manipulate the calculation. That's another one that's a bit of a revisit from the addition strategies. But we're going to look at how we can tomorrow not just use doubling, but use doubling and halving together. So it's kind of an extension of today's video, and it's probably my favourite strategy of all. So I really look forward to seeing you tomorrow. It's it's a slightly shorter video because it's one little strategy, but I hope you'll come back tomorrow and we'll be able to start to conclude all the multiplication strategies. Thank you very much, and I shall see you then.
And a quick recap of all the strategies that we've been looking at over the past 6 days. We've now looked at factorising, reordering, partitioning, rounding and adjusting, all of the different doubling strategies, and tomorrow we're moving into manipulate the calculation. So fingers crossed you'll find that's probably my favourite of all the strategies, so hopefully you'll find that one useful as well. So thank you very much for watching this video, a little bit longer video today because we were looking at quite a lot of different things connected with doubling, but I hope to see you tomorrow for a much shorter video that takes on board the strategy manipulate the calculation. And I'll see you then.